This is a NEET 2021 question in mechanical thermal properties of solids. Problem is like this. A cup of coffee cools from 90 to 80 in T minutes when the room temperature is 20. What's the time taken by the similar cup of coffee to cool from 80 to 60 at the same room temperature of 20 degrees centigrade? The first thing we need to know is, to solve this problem we shall use a law called Newton's law of cooling. The rate of loss of temperature to the surroundings of a body is directly proportional to temperature of the body minus surroundings. But when the temperature of the body is given with two values of 80 and 90 like this, I shall take the average of the two bodies to get the temperature of the body. Once you know that, you can take case 1. Case 1, it is given that 90 degrees centigrade to 80 degrees centigrade in room of temperature 20 degrees centigrade in a time of t seconds. Let's apply these conditions into this Newton law of cooling. Change in temperature dt changed from 90 to 80 by change in time small dt, time of t minutes, equal to some constant into temperature of the body. It changed from 80 to 90. So the average of that has to be taken into consideration. Minus surroundings is given as 20. Simplify this. 10 by t equal to k of 80 and 90 average is 85 minus 20. We call this as equation number 1, case. Now let us take case 2. It is given that it is cooled from 80 to 20 in a room of 20 degrees centigrade. 80 to 60 in room of 20 degrees centigrades in an unknown time. Let me call the time as x. We have to calculate that x. Apply this values also into this formula. Change in temperature is 80 to 60 by in a time x equal to same proportionality constant. Now the average of this 80 and 60 has to be taken and the same surroundings 20. So 80 minus 60 is 20 by x equal to k of 80 and 60 average is 70 minus 20. This is equation number 2. Let's divide this equation number 1 and 2. That gives 10 by t on the first equation, 20 by x in the second equation. X of 85 minus 20, k of 85 minus 20 in the first equation by k of 70 minus 20 in the second equation. 10 by t by x by 20 equal to k gets cancels. 85 minus 20 is 65, 70 minus 20 equal to 50, and twice. So x by 2t equal to cancel with 5, 5 13 65, 5 tens are 50. This is 5 times. So x equal to 13 by 5 times of t. That's the answer for the problem. So to solve this problem, we use a law called Newton law of cooling, which tells you that when the temperature of the body and surroundings is small, the rate of loss of temperature to the surroundings is directly proportional to temperature difference between the body and surroundings. Knowing that, you can solve and get to the answer quite easily. That's it.